Good morning, everyone. Thank you for joining the Boston University Institute for Sustainable Energy, ISE, for today's webinar on integrating advanced manufacturing and climate change policies, part of our Energy of the Future series. My name is Andre Sharon. I'm a professor of mechanical engineering at Boston University and an affiliated member of ISE. I'm also the director of the Fraunhofer Center for Manufacturing Innovation. To give you a quick introduction to ISE and our sustainable energy research, we are an interdisciplinary, university-wide institute focused on academic analysis with real-world impact. This means that we often collaborate with external stakeholders to help business leaders, energy providers, financial markets, and public policymakers to develop and implement equitable and effective decarbonization strategies at all scales, from local to global. All of ISE's research is available on our website at bu.edu/ISE. We have three distinguished panelists today. Colin Cunliff, Senior Policy Analyst at Information Technology and Innovation Foundation, ITIF. Henry Kelly, ISE Senior Fellow and Energy Technology Expert. And Zoe Lipman, Director of Manufacturing and Advanced Transportation at the BlueGreen Alliance. They will each give a 15-minute presentation. Following the three presentations, we'll have a Q&A session, so please submit your questions by clicking the Q&A button icon at the bottom of your screen. Also, I'd like to give a big thank you to our sponsors, Northeast Clean Energy Council, our series co-sponsor for Energy of the Future, and the only organization that covers all of the clean energy market segments in the Northeast with business, innovation, and policy leadership. I'd like to also thank the Information Technology and Innovation Foundation. Jointly with ITIF and Fraunhofer, ISE is developing a roadmap for integrating advanced manufacturing and climate policies. Please contact ISE if you want more info on this or would like to contribute. Fraunhofer Center for Manufacturing Innovation at Boston University, bridging academic research and industrial needs. The BU Student-Run Energy and Sustainability Club and the Clean Tech Club. Okay, before I turn it over to our panelists, I would like to make a few remarks about manufacturing in general. Integrating advanced manufacturing and climate change policies is a very timely topic and one which has generally been neglected. While most of the energy and greenhouse emissions narrative seems to focus on buildings and mobility, it is important to remember that industry is responsible for some 30% of all greenhouse gas emissions. And yet this manufacturing sector has not received nearly as much attention. Now, I'm not a policy guy, I'm not an economist, I'm an engineer. But I've been involved in manufacturing R&D for a long time, both in industry and academia. I started out at IBM developing manufacturing equipment. I then went to MIT where I co-founded and led the MIT Manufacturing Institute. And finally, some 20 years ago, I came over to BU and Fraunhofer. For much of this time, manufacturing was not on the radar of politicians and policymakers. In fact, highly respected economists were telling us that there is nothing special about manufacturing. It's all about a high GDP per capita. We can be an economy of services and innovation, they told us, while we let others do the manufacturing. It is only in the last decade or so that we saw a resurgence of interest in manufacturing. And I believe there were two reasons for that. First, it came to be realized that manufacturing better distributes the wealth among the population, strengthening the middle class and alleviating the animosity between the so-called 1% and 99% of the population. Some of you may remember the campouts on Wall Street and in other cities. And second, It was realized that you cannot innovate in isolation without the manufacturing base to sustain the innovation process. In other words, you cannot innovate without being able to produce those innovations. Recently, there's been a lot of talk about reshoring manufacturing, and in fact, the federal government funded a network of manufacturing institutes to strengthen our manufacturing base. Reshoring current manufacturing, in my view, however, is a political aspiration and not a realistic goal when the entire supply chain lies overseas. Sure, we've seen some symbolic gestures from industry caving into political pressure and reshoring some final assembly operations while the bulk of the components are still manufactured overseas. But these are just gestures with little impact on overall jobs creation. For the first time, we are now at a juncture where we can actually reclaim manufacturing here in the US. If industry, and especially heavy industry, is going to comply with climate change policies, manufacturing will need to be practically reinvented. We need to invent new processes, new materials, new sources for production of raw materials and gases, including biological sources, etc. This presents a once-in-a-lifetime opportunity to reinvent and reestablish a strong base, manufacturing base and supply chain right here in the United States. And this is what excites me most. However, if we don't move quickly and decisively, the window of opportunity is going to close because Europe is already off to a running start and China and Japan are not standing still. We cannot miss this opportunity to reclaim manufacturing. With that, I would like to introduce our first speaker. Colin Cunliff is a senior policy analyst with the Information Technology and Innovation Foundation, where he focuses on accelerating clean energy to address climate change. He co-authored the recent book, Energizing America, a Roadmap to Launch a National Energy Innovation Mission. Prior to joining ITIF, Dr. Cunliff worked at the US Department of Energy Office of Energy Policy and Systems Analysis, EPSA as it is known. His talk examines innovation opportunities and the federal role to advance clean manufacturing in the United States. Colin, if you will, please.
Great. So thank you for having me. I'm very excited to join this conversation. And again, I want to remind you to submit your questions on the Q&A and we'll get to them at the end. I'm looking forward to a great discussion. So the title of my talk, Greening Industry, the Forgotten Climate Wedge. I'm going to start with a couple figures that really crystallize for me the importance of developing an innovation agenda for industrial decarbonization. So this first figure shows why I call the industrial sector the forgotten climate wedge. Now, the first principle in designing a clean energy research portfolio should be that we match the portfolio to critical decarbonization needs, but we're obviously not doing that. So on the left, you see US greenhouse gas emissions by economic sector. Transportation comes in first, accounting for 29% of direct US greenhouse gas emissions. That's followed by electricity. And then the industrial sector accounts for 22% of direct US greenhouse gas emissions, followed by buildings and agriculture. Now, if you distribute electricity-related emissions according to their end use, then the industrial sector jumps to 30%, larger than the transportation sector. Now on the right is the Department of Energy's research portfolio broken down by sector. And the first thing that jumps out is that nearly half of the funding is devoted to electricity. Now, this makes sense when you think about the size and number of DOE programs that focus on electricity, like the Office of Nuclear Energy, fossil energy, and then the renewable power offices. There are four: solar energy, wind, water power, geothermal, and we're also including fusion energy in this bucket. Energy science and cross-cutting technologies come in second. They account for about a quarter of the portfolio. Next is transportation. And then just 6% of DOE's research portfolio is devoted to the industrial sector. And that's primarily in the advanced manufacturing office. Now, I also want to point out that decarbonization is not necessarily AMO's mandate. Their primary emphasis is on reducing energy costs for US manufacturers, and their focus has historically been on energy efficiency and process intensification, and also electrification. And don't get me wrong, these are important areas that DOE should be researching, but without that decarbonization lens and without the focus on net zero emissions, there may be decarbonization tools that DOE is missing. Now, the industrial sector is also more challenging to decarbonize than other sectors, and this graph shows why. So this is modeling that was conducted for the Quadrennial Energy Review that came out in January 2017. It was economy-wide, but I've got here the industrial sector direct energy CO2 emissions. And this uses 3 technology scenarios. So it projects emissions under these scenarios. The black lines show emissions under a reference technology scenario. And in this scenario, technology evolves without the help of DOE. The blue lines show emissions under a scenario in which DOE meets its technology targets for clean energy. So DOE sets a lot of cost and performance targets for clean energy that are generally conditioned on receiving constant funding levels for the department's research, development, and demonstration programs. So if DOE meets its targets, then emissions decline slightly from the reference scenario. The orange lines show emissions under a scenario in which funding for DOE's RD&D programs is doubled, which allows DOE to set more ambitious cost and performance targets for clean energy. Now, each technology scenario is also layered with 2 additional policy scenarios. These are the dashed lines. So the long dashes are labeled CP10, which stands for a carbon price of $10 per ton starting in 2017 that increases at 5% annually. The short dashes are labeled CP20, which stands for a carbon price of $20 a ton, again starting in 2017 and increasing 5% annually. So they would reach $50 and $100 per ton by 2050, respectively. These are fairly low carbon prices and certainly a lot lower than many of the carbon price legislation that has been proposed. So there are 3 sets of projections, each with a distinct color and corresponding to distinct technology scenarios. And a couple things stand out. The first is that a carbon price, at least at these low levels, doesn't really do much to reduce emissions from the industrial sector. And second, even under the ambitious technology scenarios in which funding for DOE doubles, emissions don't really budge. And why is that? There are a couple reasons. First is that, again, the industrial sector just really is more challenging to decarbonize than other sectors. There aren't many commercially available clean alternatives to industrial processes the way there are for the electricity sector. So if these projections are discouraging, they should be. The good news is that in other sectors, it's not quite as discouraging. So in the electricity sector, for example, I believe emissions fall more than 90% under some of these scenarios. And that's simply because clean energy or clean electricity generation, such as solar and wind, is already cost competitive with fossil generation in many parts of the country. So even a tiny carbon tax can do a lot, and more ambitious innovation can do a lot. But again, in the industrial sector, we just don't have a lot of those alternatives that are commercially available. Second, this also just reflects the fact that, again, the federal government underinvests in clean manufacturing research. So even if we double funding, we're doubling funding from such a small baseline that we're not able to move the needle that much. Now, a third reason, and this is actually a bit of good news, is that this is also just partly a crappy model. So this used NEM, the National Energy Modeling System, which EIA uses for its annual energy outlook. It has a good representation of the power sector and transportation sectors, but in the industrial sector, it doesn't have a good internal representation of many clean energy alternatives. So these projections are likely a little bit overly conservative. So I want to dig deeper into the industrial sector. Again, the pie chart on the left just shows energy-related CO2 emissions by sector, this time with electricity emissions distributed. And the industrial sector emissions are pulled out in the pie chart on the right. Now, a small share are associated with non-manufacturing sectors, but the vast majority of industrial emissions come from manufacturing. And within manufacturing, 5 energy-intensive sectors account for more than 70% of manufacturing energy CO2 emissions. And these are petroleum refining, chemicals and plastics, iron and steel, food products, and cement. Also, I should note that these are only energy CO2 emissions, so these numbers do not include process emissions, particularly from calcination in cement manufacturing, and I'll discuss that more in a minute. Also, just a heads up, the Advanced Manufacturing Office is currently producing industrial decarbonization roadmaps for these 5 sectors, and these should be out soon. Now, why are these emissions from heavy industry so difficult to eliminate? I'm going to focus just on cement, iron and steel, and chemicals. And I think Henry is going to talk about some of the other sectors and lower temperature challenges. But for heavy industry, there are 3 common challenges. And the first is that many industrial processes require high temperatures to drive those processes. And today that's almost exclusively provided by fossil fuel combustion. Now, it's possible to generate high temperature heat from electricity, but it's impractical and costly, at least with current technologies. And often these manufacturing plants are built around the combustion process and have highly integrated waste heat recovery systems, and electrifying would require complete plant redesign. Now, process emissions are also a real challenge. Process emissions are emissions from chemical transformations that cannot be eliminated by switching to clean energy. So here's a simple example. A key step in cement manufacturing is the calcination of limestone to make lime. So you take limestone or calcium carbonate, CaCO3, heat it up to very high temperatures, typically around 900 degrees Celsius, to get lime, which is calcium oxide, and in the process, you boil off carbon dioxide. So even if you are able to use zero carbon heat, you're still left with these process emissions. And for cement in particular, process emissions account for 60% of total emissions from cement manufacturing. The third challenge is the long lifetime of industrial plants, often 30 to 40 years, which leads to slow stock turnover and slow investment horizons. So now there are several decarbonization levers for heavy industry. In the near term, there are certainly opportunities for demand management, for improved energy efficiency, perhaps even some material substitution. But deep decarbonization is going to require one or more of these other technologies. So hydrogen can be combusted and is capable of achieving high temperatures similar to that of fossil fuels. It can also be used for direct reduction of iron ore in the steelmaking process. Electrification of cement kilns or furnaces in chemical manufacturing also holds promise. And in steel, we already use electric arc furnaces to recycle steel. And some companies are also researching direct electrolysis of iron ore. And then carbon capture, use, and storage is really the only way to address process emissions. And then finally, there may be sector-specific transformational processes that are still in early pilot stages that are also worth exploring. So here's just one example from the decarbonization roadmap for cement in California. And in this assessment, emissions from cement manufacturing are about 11 million tons of CO2 in 2040 under business as usual. And by pulling on these 4 levers, the roadmap is able to reduce emissions by around 75% by 2040. The 4 levers are energy efficiency, clinker substitution, fuel switching, I believe that's to natural gas, and carbon capture, use, and storage. Now, innovation takes a long time, so I want to emphasize why it's so important to start now. That's because basically, historically, it has taken between 20 and 70 years for new energy technologies to go from a first prototype to market introduction, and then from market introduction to capturing 1% of market share. So even recent success stories like lithium-ion batteries for electric vehicles or LED lighting take 20 to 30 years. LED lighting in the United Kingdom, for example, was first introduced in the market 10 years after a working prototype was created. And then it took another 10 years just to capture 1% of the market. So here are some of the technologies in the International Energy Agency's 2-degree scenario, the Sustainable Development Scenario, and their timelines for achieving that early 1% market share for CCUS and cement, for CCUS and steel, for hydrogen-based direct-reduced iron. Many of these technologies are anticipated to first be introduced in the market in the mid to late 2020s, and then to achieve that 1% market share in the mid to late 2030s. So finally, what can we do? What are our next steps? How can we develop a clean manufacturing RD&D strategy? I'll just note that I do have a book out, Energizing America, with co-authors Varun Sivaram, David Hart, Julio Friedman, and David Sandalo. And we propose a national energy innovation mission to triple federal investment in clean energy RD&D to $25 billion by 2025. And a big part of that is ramping up funding for these historically underfunded areas. And the industrial sector is one of the most important. Some of the recommendations in the book, and I just pulled a few, of course, more funding for industrial decarbonization, more focus. This could be through appropriations for the Advanced Manufacturing Office, also through new legislation such as CETA, which is a Clean Industrial Technologies Act. We can also refocus the AMO on decarbonization and broaden its focus beyond just energy efficiency. The industrial decarbonization roadmaps are a good place to start. And then when we look at other parts of DOE, there are a lot of other parts that we could use more effectively. So we already have a hydrogen and fuel cells technologies office. This primarily explores applications of hydrogen in the transportation sector and fuel cell electric vehicles. So we believe that that focus should be broadened to include hydrogen applications in the industrial sector. And then the same for carbon capture and storage. DOE has a fairly large program, but it is all entirely in the coal program within the Office of Fossil Energy. So we really need to be exploring applications for carbon capture in industrial sectors such as cement, such as steel, such as chemicals, and not just coal power generation. And I think I'm running about out of time, so I will turn it over to Henry, and I'll just say thank you and follow me on Twitter. And I'm looking forward to your questions.
Great, thank you very much. So the next speaker is Henry Kelly. Dr. Kelly is a senior fellow at the ISC. He is an expert in technology policy and has worked extensively on energy, information, education, technology, and nuclear weapons. In addition, Dr. Kelly is the chief scientist and industry partnership leader at the University of Michigan Institute for Data Sciences. He previously served as the chief scientist in the U.S. Secretary of Energy's New Energy Policy and Systems Analysis Organization. And prior to that was a principal associate director for Environment and Energy in the White House. Henry.
Hi, everybody. I should remind you that I am currently not with Michigan, but with Boston University's Institute for Sustainable Energy. And what I want to do is spend a little time building on what Colin has just told us and talk a bit about the project that Fraunhofer, Boston University, and ITIF are working on and trying to look at ways of achieving climate goals and rebuilding U.S. manufacturing. So with that, I want to start off by just putting this up. This is not a surprise to anyone, but I just wanted to make sure that we understand what we're up against. This is a 1.5 degree scenario that was put together by IPCC. And if you buy yourself another 10 years or so, you have the 2-degree scenario. But there are two things that I wanted to point out here. One is the obvious fact that we're almost certainly not going to be able to make this, even with a concerted effort. For one thing, the US has lost a number of years here that were assumed in this scenario. And even these things assume that you're able to go negative and you're going to so-called overshoot. So even with this ambitious reduction, you're going to have problems meeting the 2-degree or 1.5-degree scenario. But the second thing is the extremely rapid reductions that are required to meet these climate goals. And this means really a massive change in the certainly the manufacturing infrastructure and the products that are in our economy. And this is indeed unprecedented, but it's also an unprecedented opportunity for innovation. And so this touches manufacturing in two ways. One is, of course, we're going to have to rebuild the manufacturing infrastructure around these innovative, clean approaches. All of these are, in fact, innovations that also provide other benefits. One of the benefits being really an interesting opportunity for employment in rewarding new jobs. But the other part of it is that if you're going to actually rebuild the economy in such a dramatic way over the next 20 or 30 years, you're going to create a huge amount of employment in just building the stuff that you need to meet these goals. And that means not just the cars and buildings, but it also means a lot of manufacturing equipment. And if you look at where the jobs are in manufacturing, it's making equipment that is one of the biggest employers. These total to about 2/3 of the total US manufacturing employment. But you can see making stuff, making machinery, making cars and trucks, food manufacturing are huge employers. And so where a lot of the large fossil fuel industries really are not terribly large employers. So one of the things that we want to keep in mind here is the opportunities created here to generate manufacturing jobs. And I'll talk about some of that later. So in our project, we have 4 main themes. The first of which, one of these Colin already very adequately covered, that is these high temperature processes that are responsible for the lion's share of the direct energy consumption in industry. But we're also looking at low temperature processes, which is basically the unromantic process, mostly of heating stuff and taking water out of stuff and separating things. But then we have 2 cross-cutting projects, one looking at bio-based manufacturing, which is a sort of a wild card in this and is a growing share of US manufacturing, as it turns out. And the final one is materials. And here there are 2 themes. One is the actual design of materials to meet the requirements of these new industrial processes. And then, of course, efficient use of the materials, including recycling. So with that, let me start off on low temperature processes. As I said, it has to do with heating and cooling things and separations. And here, there's a lot of innovation that's possible in technologies like heat pumps and various kinds of currently refrigerant-based systems. A goal here is to try to find a way to get rid of the toxic refrigerants and achieve very high efficiency. And there's some really interesting new ideas. The second is just removing water from stuff. And so in the industrial processes, the food production and paper making are the 2 big consumers of energy in these low temperature areas. But one of the interesting things is that if you look at heating, cooling, drying at low temperatures, it's a big chunk of the energy used in buildings and homes and commercial buildings. And taken together, it's nearly 18% of US energy consumption. So the opportunity space here is for technologies developed under this theme is very big, both in industry and potentially in buildings. And one of the things that has become really apparent in meeting the climate change is that as people get more money and as the climate warms, the demand for air conditioning goes through the roof. And something like 2.4 billion units are likely to be sold by 2050, according to IEA. And so the really an interesting question here is who's going to actually make this stuff? Who's going to make these products? And that's where the manufacturing connection really becomes powerful. Second was looking at the bioprocesses that I talked about. And this is, the question is, why now? What's different? Well, it turns out that biological processing is on a curve that would even make Moore's law jealous. The cost of sequencing DNA and the cost of taking sequenced DNA and converting it into proteins is just plummeted. And that's, yes, that is a log scale on the left side. So you have all of a sudden opened up a big opportunity space in using biological processes, which of course can do extraordinary things, using available materials and at room temperatures. And it's led to a very rapid increase in the production of synthetic materials using biological processes. And this is in agriculture, in pharmaceuticals, and increasingly in industry. And this becomes very interesting as you start trying to say, what are you going to do about the petrochemical industry, which is a very large chunk of industrial energy use, and for which there are not really many obvious substitutes. But if you could, it is certainly technically possible to make virtually any of the products that are coming out of the petrochemical industry, including plastics and fibers and many other things, using biological processes. And as it turns out, it's also possible to make food products directly. This is synthetic meat, synthetic milk products, and many other things. And this has gone from being kind of a backwater to a really serious investment area in the US. And there's been a very significant increase, mostly in private investment in this sector. But it's certainly something that we want to explore, and it's a place, both the production of chemicals and production of food, the potential for really large manufacturing growth in the coming decades, something that could have a big effect both on employment and on the climate. And the final point is or a theme we're pursuing is materials. And here again, the revolution in simulations and very interesting advances in the way you can measure materials at many different levels make it possible to really design materials to meet some of these very ambitious goals, which would be creating very lightweight, very strong materials, creating materials that can be recycled and disassembled, and then creating simulations that help you figure out how to produce these things at scale affordably. And of course, there are a lot of the technologies I've been talking about, whether it's membranes for separation or some of the things that Colin talked about in advanced steel making and cement production, involve advances in materials. And then, of course, there's also the biological synthetic biology approaches to this. And I just put this up because if you look at how nature has used materials, you have this additive manufacturing that's self-assembled, but it's self-assembled. It ranges from nanoscale up to macro scale. And there's been a lot of interest in whether we can use biological techniques to create novel materials and even novel structures. Finally, recycling. The potential here is significant for reducing the energy required if you can recycle material. The reality is that recycling is very, very rare, and there are many reasons for this. One of them is that the materials themselves are often hard to recycle, and most plastics can't be recycled more than a few times, even if they are collected. But this is a place where a material design could help you enormously, both by creating materials that are recyclable, also materials that are degradable in ocean water and in soils. And then finally, there's material substitution, where you can use perhaps natural materials to substitute for things that you've been using steel, cement, and other materials for. There's sort of two dimensions. There's one is that clever design can reduce the amount of steel and cement and other things that you need to produce a function. But also there's growing interest in things like using structured wood. And I just throw this up as an amusing example of a very large wood building that has managed to survive for many generations. And multi-story wooden buildings are in fact becoming a very interesting option in Europe and elsewhere. So with that, I'm going to turn it back to Andre. Be happy to answer questions. And as you can see, we're trying to cover a very broad landscape, and we really would be eager for help, ideas, suggestions in the space that I've just described. So thank you.
Great, thank you, Henry. The third panelist is Zoe Lipman. Zoe's Director of Manufacturing and Advanced Transportation at the BlueGreen Alliance, where she leads the policy and advocacy on clean technology manufacturing, advanced vehicles and transportation, and related economic topics. Prior to joining BGA, she led the National Wildlife Federation's program on fuel economy and advanced and electric vehicles, and previously headed the organization's Midwest Climate Policy Program. So we will focus today on securing good jobs in a cleaner economy. Zoe, please.
Hi, thank you so much, Andre, and it's great to be here. I think Colin and Henry have flagged the huge range of manufacturing and jobs opportunities in stepping into the opportunity in advanced manufacturing in the US. I'm going to talk a little bit about what it takes to make those gains real. And let me share my screen here. So for folks who aren't familiar with the BlueGreen Alliance, we unite some of the nation's largest labor unions and environmental organizations to solve environmental and climate challenges in ways that create and maintain good jobs and build a stronger and fairer economy. Sorry, I'm just trying to get having a little trouble advancing the slides here. Sorry. Oh, there we go. Great. In 2019, we put together something called the Solidarity for Climate Action platform, which laid out our thinking about a climate agenda that jointly addressed the economic crisis and the climate crisis facing working people. As a key part of that, we saw manufacturing, addressing manufacturing as a key part of that. That we can't rebuild prosperity if we fall behind the rest of the world in building the technologies of the future, or if working people don't see the gains from a clean economy. And we subsequently put out a much more detailed manufacturing agenda, which I'll talk about later. And that came out at the end of 2019. We felt that these issues were absolutely critical at the end of last year, but I think where we sit today, they're even more critical. The COVID crisis has underscored how important manufacturing is, what it means, but also, and as manufacturers have stepped up to meet some of the challenges of the current crisis, but it also underscored just how serious some of the gaps in our supply chains are, not just for things like vaccines and PPE, but for many products that are of economic, critical to our economy. And it also revealed profound gaps in equity, in worker safety, and underscored that our economy was already broken, and there was an urgent need to address these issues. As everyone has previously spoken about, manufacturing really matters both for the climate and for the economy. As folks have mentioned, I'll throw out a few more statistics. Nationally, manufacturing employs 1 in 11 workers, 2 trillion a year in GDP. That's about but when you figure in all the products and services associated with it, it can be it can come up to as much as 1/3 of total U.S. economic output. It also accounts for a huge amount of the innovation that this nation does, 2/3 of private sector R&D. And as Andre mentioned in the upfront, it has been a proven pathway into the middle class for millions of workers, which unfortunately is no longer available, a path that is no longer as available as it should be to American workers. And as a result, addressing this shortfall is an essential part of an effective recovery right now, and to sustaining it through some of the ongoing investments that Colin and Henry mentioned over the long term. Manufacturing is also essential to addressing the climate crisis. And I loved one of Colin's early slides that put this very clearly from a standpoint of just how important emissions from the industrial sector are and how much more we need to do about it. But I will put maybe a sort of different spin on it. Manufactured goods are absolutely critical to meeting the climate challenge. Whether we're thinking of wind turbines or solar panels or the next generation of buildings or infrastructure or vehicles, all of these depend on manufactured goods. And in particular, the energy intensive industries that Colin and Henry were speaking about are absolutely fundamental. And I'll get to that in a little bit more detail further down. But they are also a growing source of emissions. Furthermore, we've often seen, and we've recently seen over the past decade, and even right now, loss of a great deal of our basic industry. Think of steel or aluminum smelting. And when those jobs move overseas, when those industries move overseas, not only are we losing jobs at home, but we tend to be offshoring both labor and pollution issues, because much of the production elsewhere in the world is dirtier for every roll of steel that we produce, and it may be built with lower labor standards. And so for many reasons, ensuring that we reinvest in these critical industries, prepare them for the future, and provides a real opportunity both to secure high quality jobs here in the US, but also to lower emissions overall. All is not perfect in the manufacturing sector, however. We have for decades, manufacturing workers for decades have been facing all kinds of challenges. Offshoring, as I just mentioned, outsourcing that results in lower conditions. And sorry, I've got little pops up here. In lower working conditions and declines in union density, which have also contributed to the decline in the middle class that Andre mentioned up front. Today, we've seen some of those weaknesses in the manufacturing economy really revealed more starkly. We've seen terrible issues of worker safety in the context of COVID in manufacturing facilities. We've realized how essential many of these jobs are, and how we have disregarded the conditions that workers are working in these critical industries. And like much of the COVID crisis, these impacts have been disproportionately felt by low-income workers, by Black workers and workers of color. And if we're going to go forward, we need to come up with solutions in which our climate, economic, and racial equity crisis are solved together. And where we sit now, clean tech's example in this space is has been mixed. We have a great examples of building the technologies of the future with high labor standards, and this gets to something that Henry mentioned, and with a real attention to building the full supply chain and not just final assembly, though we absolutely need both. And we have other examples in which new industries are putting into place with, I guess the best way, this is not original to me, but many folks have talked about how in many places we're building 21st century technology with 19th century labor and working conditions. And that's not innovation, but it's also not a model that's sustainable for industries as we move forward. The good news is that we have the opportunity to head down a stronger path both for the economy and the climate. And we really are at a crossroads here. The climate and the economy are changing rapidly. And our competitors overseas are moving fast, as also was mentioned earlier, and they're using all the tools at their disposal to capture the benefits of this technological change for their workers, their manufacturing, their economy. Getting out ahead of this change, leading on climate and on clean technology and advanced industry is absolutely essential to growing manufacturing and to good jobs. But, and this is the policy area that I want to talk most about here, is not sufficient to guarantee it alone. Clearly not acting, falling behind can be devastating. But if we look at, for example, at the auto sector, and the background here is a picture of the automotive assemblers and suppliers in the advanced vehicle sector, which we define very broadly because really innovation is happening at every part of the automotive sector today. The auto sector is at the heart of the manufacturing economy, as also was mentioned earlier. We have examples in this industry of how over the last decade, as we've moved to far higher fuel economy standards, we've invested in securing and enhancing manufacturing and manufacturing supply chains here. We've seen tremendous growth in automotive supplier investment and jobs. At the same time, however, this industry continues to face ongoing pressures on offshoring and outsourcing, and as does the rest of the manufacturing industry. And as we move to electric vehicles, that transition could either take the path that we've seen in advanced fuel efficient technology and drive domestic investment by firms all over the world to build these technologies here, or we could see directions that take us further, where we don't in fact build the electric propulsion and battery cell and other technologies here, and we see a hollowing out of the supply chain in the auto sector. The good news is that the choices we make now can impact that outcome, and we have a range of tools at our disposal to, and some of which the previous speakers have mentioned, to ensure that we strengthen those supply chains, build a density of our supplier network in the US, and ensure that we're building good jobs in this sector. So I use that as one example. Another, I want to circle back to the energy intensive basic materials sector that Henry and Colin raised. This is also really critical. As I mentioned before, energy intensive basic materials are at the heart of the economy, both today and tomorrow. It doesn't matter whether you're building, today's infrastructure or tomorrow's infrastructure, a conventionally fueled vehicle or a electric vehicle, for that matter, a flying vehicle, which has been promised forever and we still haven't seen. Flying cars. There are some interesting prototypes at the moment. Regardless, these rely on a whole range of energy-intensive materials: steel, aluminum, carbon fiber, glass. We rely on these, rely deeply on these industries, and as I mentioned before, when we offshore them, there are a variety of both climate and economic costs. We have a range of policies in this sector that can support building and sustaining domestic production of these higher standard technologies, and coupling some of the incentives that we use in procurement and in a range of other investments to support the companies that make the investments in the advanced technologies and new processes that Colin and Henry mentioned. But to get there, we need a proactive strategy. So real quickly, I mentioned we have a manufacturing agenda. What it focuses most on is putting, for lack of a better word, steel in the ground to really jumpstart, make an investment at scale in a new generation of manufacturing across a range of tools, but to do two key things. Reinvest in critical clean technology and supply chains, similar to the story I told in auto. And then secondly, to transform basic energy intensive industry. And to do that, there's a whole range of tools we have. I'll talk real quickly. Invest at scale, and I'll touch on a few options we have right away in a moment. Second, innovate to transform industry. The other speakers have spoken at great length of the opportunity here. We also want to see a major doubling down, enhanced investment in R&D and innovation, but particularly to transform the energy intensive sector and to fill key clean technology supply chain gaps. Key to filling supply chain gaps is also ability to be able to economically, socially, and environmentally sustainably produce critical minerals and materials of all kinds, and to recycle and reclaim them soundly. Third, to use public investment wisely, whether that's public procurement or the big investments we make through our tax credits and other incentives, and to ensure that those support domestically manufactured goods, especially in these emerging industries. And finally, fair trade, tax, and labor standards, all the rules that go behind supporting this important innovation and job growth. And then I want to say something about how all of those things are done. It's really critical that we build in a focus on manufacturing and on good jobs and equity at every point in the policy we think about in manufacturing. And that's really focusing on a couple key elements. One is that we're focusing on creating family sustaining good jobs across the economy and across the manufacturing supply chain through a variety of standards and other measures. Maximizing, targeting our investments, maximizing the benefits to workers and communities that need them most, systematically strengthening clean technology and materials manufacturing and supply chain. And what I mean by there is that we're not putting all this effort into rebuilding these industries on the one hand, and then have other policies that take that away. Reduce pollution throughout. Look at high environmental and health and safety standards to make our communities and workplaces safer, more resilient across the board. And then, really critically, investing in training and jobs together. Increasing and improving the pathways into family supporting manufacturing jobs and technical careers, and doing that as part of the job creation strategy, not separate from it. And so to close here, I wanted to talk about what are some of the exciting opportunities right now in this space. We've talked a lot about really critical innovation and R&D and demonstration. But we also, and especially in this moment where our economy is in crisis, we have some opportunities to sort of put that to work right away. And of course, the first priority for all of us are the key things we need for overall economic recovery, getting COVID under control in a serious way, investing in recovery in ways that address a whole range of critical issues for communities, small businesses, workers. But also that there's stuff we can do now to jumpstart action on infrastructure and on manufacturing. And I want to talk through a couple of those super fast as I close here. First, as I've said before, we have a chance to invest at scale in transforming energy intensive industry. And this is really getting back to, I think it's Colin's early slides. We have opportunities now to roll out far greater investment in the full range of the types of energy and emissions reducing strategies for energy intensive industry, to jumpstart deployment of the technologies we know now, from things like energy efficiency and smaller scale process improvement that many companies can do with the right incentives. Secondly, to provide the kinds of financing for the next phase, the larger process improvements, the integration of new kinds of low carbon processes and partnerships. And finally, and this is not something all of which can be done today, but there are certainly examples that can be, to begin creating a set of incentives to cite first-in-class facilities of the kinds that many mentioned, ultra-low emissions ways to produce steel or other products integrated with materials production and things like this. These don't just have to be piloted, though it's important to do that too, but there are opportunities where these plants exist at commercial scale in Europe or in the Middle East. We need to begin putting some of those on the ground in America. Second, there's a ton that can be done to reinvest in building key emerging technologies and critical supply chains here across a range of sectors, a range of geographies. I'll flag one thing really quickly, which is to focus on investing manufacturing and converting facilities that may be at risk of closure or that have closed from a previous manufacturing use to the next generation of technology in those industries. We have a bunch of tools designed to do that and already in DOE and elsewhere, and there's some really exciting opportunities to jumpstart that now. As I said before, we can target these investments in the workers and communities and sectors that need it most. Again, opportunity to use some of the programs and tools that others have mentioned, our technology hubs, NIST, MEP, many others, to focus on really rebuilding and strengthening and opening suppliers and assembler facilities in key geographies. And maybe just to close out, there's equal opportunity for innovation in producing the clean and advanced products of the future in ways that are also clean and just for non-toxic, clean, don't pollute locally, don't harm workers, and that's also a very critical next step. Early on, I showed a slide why manufacturing matters. There was a huge offshore wind nacelle, a huge manufactured product. There's only one problem with that slide. That picture is taken in France. And what we want to see is have those nacelles built here. There was news just yesterday that Ørsted, a major offshore wind producer, will be building offshore wind across the northeast coast in the U.S., has entered into a pact with U.S. trade unions to grow the offshore wind workforce and to do joint training and workforce development, and then put folks to work doing this technology. This is really exciting news. It only happened yesterday. But it flags for us the next step, which is also beginning in places, but to ensure that we capture the manufacturing supply chain for these wind turbines in the US as well, with good jobs, and for that matter, that the operations and maintenance of technologies like this is also done in a hydro manner. And with that, I'll turn it back. Thank you.
Thank you, Zoe. We are now in the Q&A portion of this webinar. So again, if you have any questions, please use your Q&A icon at the bottom of your screen. So the first question that came in actually is a tough one. It's addressed to all the panelists, and it deals with where in the R&D sort of cycle, R&D and implementation cycle do you invest? So the question is, how would you allocate public funds between basic science and labs, venture stage products and process innovations, demonstration scale-ups or pilots, financial assistance to first to market in order to bring down the learning curve? Are these ratios highly industry specific or tend to be similar across industries? Colin, why don't you take a first stab at that, and then we'll let the other two panelists chime in.
So industry-specific ratios, geez, I don't know. One thing I will say is that right now the innovation agenda is heavily weighted towards basic energy science at the national labs, at universities, and the applied energy programs at DOE also get a lot of funding, but a huge gap in the current innovation portfolio is in this later stage development and demonstration, especially. Right now, in fact, we don't do any big demonstration projects. There were some demonstration projects funded under ARA, the American Recovery and Reinvestment Act in 2009, but the sort of large, first of a kind, if we're going to do CCUS on a cement plant, that's just not the sort of thing we've done in the past few years. So I would say that's a huge underfunded gap for sure.
Henry, did you want to chime in?
Yeah, I guess the question is extremely broad, and of course it's sort of the core of innovation policy, but it does raise the very valid question of, how do you balance investments across the research spectrum? And Colin is exactly right. We have not done a great job of this, and particularly we have gotten a lot of consensus on basic research, but efforts to try to move into more applied fields have gotten into this tangle of industrial policy, which has made it very difficult. But we've got to figure a way to overcome that. And I think that industry and labor and BlueGreen Alliance, hopefully can help us on this, will help us come up with a balance. And plainly, it does depend on what the technology is. But some of the most successful attempts to try to take basic research in the US and move them at scale have had fairly detailed roadmaps, which are updated regularly with the help of industry to try to figure out exactly where federal investment could be most productive. That certainly has worked in things like advanced lighting technology, semiconductors, and some other areas.
Zoe,
Yeah.
did you add to that?
Sure, I can jump in. I think I'd flag two things. One is that I think I share what both the previous speakers said in terms of needing to beef up the translational and commercialization side of our R&D and D, and there are several Ds. we need even more Ds, that pipeline. But I would say there are two other things. One is I think we can do a better job of ensuring what is invented here is built here. And there's, without even additional spending, to ensure that we really are ensuring that especially where we have intellectual property or others that can and should and was intended to be put to public or economically beneficial purposes, that is done. Secondly, I think the issue that someone just raised around things being in a variety of places, I think actually we would strongly recommend that in this area of industrial transformation in particular, that there's a tremendous opportunity to create a focused office at DOE that would bring together, would set a strategy to bring together all the pieces to that we already do through the AMO in particular, to connect the various parts of R&D with real deployment of these technologies in energy intensive industries. Pull the stakeholders, the different parts of DOE, connections with other parts of the government that also are relevant here. So there is really an opportunity to, again, sort of focus and target the tools we already have through maybe some mechanisms that don't take additional funding, even though we would also like to see additional funding, as the other speakers would.
Yeah.
Could I ask her, Zoe, a follow-up question here? There are many RDs and Ds, but there's also the P. You talked about procurement, and a big chunk of steel and cement is actually bought by public agencies.
Yes.
I don't know if you could expand a bit on your suggestion that procurement should be added to this portfolio.
Yeah, procurement is hugely important, as you mentioned, especially when we think of infrastructure. Not only do we have opportunities to make sure that we're utilizing our existing and potentially improved Buy America standards here, it can be critical to ensuring that we're building and not undermining growing new industries, but also that our procurement rewards the investments that these industries are making in cutting emissions and in providing good family supporting jobs, so that we work on something called Buy Clean that would ensure that we're both at the same time that we're investing to transform these industries, we're ensuring that we're also buying from our domestic producers who have met these higher standards.
Yeah, I concur with the panelists in just about every field of science. I think the US is very, very good at basic science, again, in almost every field. And the US invests more money than anyone in basic science in just about every field. So we're great at that. What we're not very good at is taking the innovations from the laboratory to the marketplace in a timely fashion. Like innovations tend to linger in the lab for a long time before they see the day of light. So I think that needs to be taken into account when you distribute the funding across the funding cycle. Okay, so the next question is addressed to Henry. What do you see as the biggest challenges facing the shift to a bio-based production of chemicals and materials, as you discussed?
Well, I think the answer is we've already given. The biggest challenge is actually scaling up. I think we've done a brilliant job of inventing test tube size samples of many, many different materials that can be produced through these synthetic biology methods. But when it comes to actually going to scale, you face another whole range of problems, which are basically manufacturing problems. And again, the point that Andre, you made at the beginning was that the only way you can actually learn what these problems are is by doing it and actually trying it at scale. And you begin to, you do a lot of, actually you invent a lot of very interesting basic science in the process of trying to solve some of these problems, but you just got to produce the stuff here in the US and find what these problems are. It's an area where the Europeans are very much ahead of us. They have been able to move to scale in some of these processes with public support much faster than we have. And it's a place where I'm hoping that we can build on the clear lead we've got in the fundamentals of synthetic biology and convert it into a really viable growing industry.
Okay. The next question is addressed to all the panelists, and it's an interesting one. You know, as we develop these technologies and certain companies invest in low carbon production, whether it be cement or steel, their products are likely to be more expensive than the conventional processes, at least until those technologies mature. How can we, so they're not going to be as competitive, bottom line. How can we guarantee a market for these companies that are investing in clean tech and developing these new technologies, although more expensive for the early years?
Maybe I could, yeah, I can jump in and with a few thoughts, and others may have others. I would say that a couple things. One is this is a great example of why we need all of our tools working together. We talked a little bit about procurement previously. There's an opportunity for sure to ensure that other kinds of public incentives also include labor standards and you know, in this case, in you know, domestic content type standards or incentives, but also that when we think about our trade rules or our tax incentives, that those also support raising standards globally and not a race to the bottom. That we are encouraging and allowing how to put it, that both are how we think about ensuring we have a fair trade regime, but also that we are enforcing some of the abuses that would drive down unfairly compete on cost. But in addition, I would really like to flag a very important thing that the questioner asked about until you get to scale. In many cases, these both labor standards and domestic content are either not nearly as not more expensive than, you know, there's a perception that they will necessarily make these products more expensive. Not only is that in many cases not true, but in other cases where it is in the short term, it is not in the long term. In other words, ensuring that you have a strategy to build up these industries locally, though it may be somewhat more costly in the short term, results in the long term in not being at the mercy of other producers. And ultimately, there's no reason why we are not able to compete in any of these industries. Maybe just one thing real quickly, just to finish the thought, many of the countries that we're competing with in these sectors are not low-wage countries. And so there's really nothing that stops us once we're able to come to speed, being fully competitive in these sectors.
I don't want to be shot here, but do tariffs play a role, Colin?
I don't know. I'm curious to hear what Zoe thinks about that. But I was going to mention procurement. I know for tariffs, I mean, that's one thing that the Trump administration tried with solar photovoltaic cells, tariffs on imported solar PV from China. And that has, I think, have spurred some investment in solar manufacturing domestically. And I think NREL has a report coming out on that at some point. but I'm curious to hear about its application in other sectors.
Henry,
Yeah,
sorry, go ahead.
Go ahead.
Yeah, good. Zoe, go ahead.
No, that was actually exactly that what I was alluding to, not giving into to short-term low costs at the expense of lost production and ultimately entirely competitive production in the US. Solar was a little bit of what I was thinking about. There was we were looking at a situation in which, panels dumped potentially below cost undermined a nascent industry. And I think it's worth looking at all the tools, reviewing all the tools that we have and ensuring that we have a comprehensive strategy that really is both fair in all the ways it needs to be fair, but also consistent with each country being able to build up their production in these critical emerging industries.
So the next question is actually addressed to you, Zoe, as well. So as we transform manufacturing, there is always the risk of leaving a large number of workers behind. How do we guarantee that that doesn't happen? How do we retrain or whatever it takes to make sure that people don't lose their jobs?
Yeah, I think the question is almost, or you've almost answered it in the way you've posed the question. I think that and this is kind of what the essence of our manufacturing agenda, I think, is that we have to the idea that technological or economic change is necessarily disruptive to workers is simply false. It's a set of choices that we make in policy. And there's a real opportunity to get out ahead of the various ongoing technological change and ensure that we are putting in place the manufacturing and jobs and social safety net and any number of other policies in place to ensure that we are in fact securing the jobs we have, ensuring workers that the new technologies are coming into the plants that we have today, and that where we have industries that have already lost jobs, we have the obligation and opportunity to do a much better job at ensuring that we're reinvesting to ensure that the manufacturing and advanced technology jobs that the new industries are bringing in are going to those places, and where communities and workers are in acute crisis, that we're pulling together the tools that we have, enhancing them to ensure that folks, both the workers and communities, are kept whole. But we hope that there are a number of efforts underway to ensure that we are doing a far much better job of reinvesting in industries that may have already felt the brunt of energy transition that was not planned correctly. But we need to be looking forward to ensure that we're not in that place going forward in other sectors. And there's no reason to think that that's inevitable. We absolutely have the tools to ensure that doesn't happen, but we have to actually act to do that.
Okay, the next question is addressed to Colin. In your presentation, you made several recommendations for reforming DOE's manufacturing research agenda. Does that require congressional legislation? Is that something DOE can do on its own? And what is the appetite in Congress these days for something like that?
So there are sort of three levers that can be pulled to affect DOE's R&D programs. The first is, what can DOE do on its own? And it is constrained by previous statutes, but it has some flexibility there. Then within Congress, I would divide congressional action into appropriations and authorizations. So authorizations will be new legislation that creates new programs. Appropriations is just a normal process of the funding of the government that happens every year. So, you know, the lowest hurdle is what DOE can do on its own, and DOE is doing some stuff on its own to. I mentioned the Advanced Manufacturing Office's industrial decarbonization roadmaps. So they previously done a bunch of energy bandwidth studies, which only looked at energy efficiency, and these decarbonization roadmaps are really a great next step to look at a broader set of decarbonization options. And they do have some flexibility. They do create new manufacturing institutes and other consortia. Within Congress, the easiest thing to do is through an appropriations process. That's because we have to fund the government every single year. So the appropriations process includes, though, not just setting funding levels, and Congress has generally given increased funding for the Advanced Manufacturing Office and for all of DOE's R&D programs in the past few years. But the appropriations process also provides an opportunity for Congress to provide greater direction to DOE for how to spend that money. Now, they generally avoid creating brand new programs, but for example, the reason that the Advanced Manufacturing Office is doing these industrial decarbonization roadmaps is because of congressional direction that was in an appropriations bill that said to DOE, you must do this. So there are some opportunities there to provide some perhaps targeted, smaller than would otherwise need authorizing legislation, policy changes, like perhaps congressional direction to DOE to look at more applications of hydrogen in industrial sectors, or to look at applications of CCUS in industrial sectors. I think those are sorts of low-hanging fruit that, because DOE already does research in these areas, congressional direction could tell them to expand it. Authorizing legislation would be needed for new programs, and this is tough even if there's broad bipartisan consensus, just because it's so hard to pass legislation right now. There has been a huge effort in both the Senate and the House just in the past 2 years to completely modernize and update DOE's research programs, and there's broad bipartisan consensus around the need to do this. In the Senate, the Murkowski-Manchin bill is composed of legislative priorities from more than 60 senators. And most of the pieces of this bill were approved by the Senate Energy Natural Resource Committee by votes of 20-1 or 19-2. So there's a lot of support for innovation, but it's just still so hard to get over that hurdle and finally become law. There's hope that it can happen in the lame duck. So that is, broadly speaking, the three levers to pull. And I would say, as to the political appetite, again, innovation has a lot of support in Congress. Support doesn't necessarily mean champions, and there aren't as many champions for the kinds of increases in funding that we've been recommending. We're losing one. Lamar Alexander is chair of the Senate Energy and Water Appropriations Committee and has led Republican efforts to bump up funding for many of these programs, and he's retiring this session. So that's something to keep in mind. We don't just need support, we need champions.
Yeah, that's an interesting distinction. So I think what will have to be the last question is addressed to Henry. Can you briefly talk a little bit more about the chemical sector? What are some key chemicals that we produce in large quantities, and what are some decarbonization pathways? You're on mute, Henry.
Yeah, there's a whole portfolio of products that come out of the petrochemical industry. And one really interesting challenge is that if the petrochemical industry starts losing markets in things like gasoline and diesel because you're going to electrification, that completely scrambles the production priorities within the petrochemical industry, because a lot of these things are byproducts. But a couple of interesting ones are production of hydrogen, which is something that obviously would be extremely useful to the industrial sector trying to decarbonize, and that you can do either with electricity, or there are some biological processes that can do that. And the second is ammonia. Again, it's largely built on either electricity and using electricity to produce hydrogen. But there's the portfolio of other things. You know, the feedstocks for chemicals are probably the most promising. So there are, you know, I won't go through the litany of chemistry there, but the trick is to get bacteria or a yeast that can take some kind of carbohydrate and turn it into one of these plastic precursors. And that is certainly feasible at scale. And I think that may be one of the most promising near-term applications.
Great. Well, I'm afraid we're out of time. I'd like to thank everyone for joining us, and I'd like to thank our 3 panelists again. It was a great discussion. Also want to thank again our sponsors, Northeast Clean Energy Council, Information Technology and Innovation Foundation, Fraunhofer USA Center for Manufacturing Innovation, Energy and Sustainability Club, and finally the Clean Tech Club. Stay tuned for details on upcoming Energy of the Future webinars continuing in January at bu.edu/ISE/events. Thank you very much and have a nice afternoon, everyone.